Section 1.4 is about multiplication of whole numbers. And so look at this. If we had 5 plus 5 plus 5, we can just say, well, that's 3 times the number 5, and that's equal to 15. In other words, we can think of multiplication as repeated addition. So some new terminology. The numbers that we multiply are called factors, and the result of multiplication is called a product. Okay, so please remember these words, what factors are and what a product is. So for example, 3 times 5, 3 is a factor and 5 is a factor, and the result is called a product. 15 would be the product. Now the symbols that we use for multiplication depends a little bit on the book you're using and the context in which it's being used, but we can write it as 3 times 5 with an X indicating multiplication, or the multiplication dot itself, or with parentheses, 2 sets of parentheses or only 1 set of parentheses. It always means the same. It's equal to 15. So these expressions are equivalent, and that's the important thing to remember. So even if the multiplication dot is left out, this is called implied multiplication. As it is here, it's implied multiplication. And you will see this frequently throughout your next few math courses as well. So how do we multiply numbers? Well, let's look at 58 times 2. So we multiply the ones, so 2 times 8 is 16. And then we write a 1 above the 5. And then we multiply 5 times 2 is 10, plus the 1 extra 10 would make it 11. So in other words, the result is 116. Similarly, example number 2, we multiply the ones. 7 times 4 is 28. Then we have a 2 here for the tens. And 3 times 4 tenths is 12 tenths, plus 2 is 14 tenths. So 14 tenths, or 148 as a result, as a product. Or the next exercise, number 3, 6 times 3, 6 times the 1 is 18. So we have an extra 10. And then 6 times 2 is 12, plus 1 is 13. So we have an extra 100 here. And 6 times 8 is 48, plus 1 is 49. 49 hundredths. So it's 4,938. And as a guided solution example, we multiply 1,348 by 5. So we multiply 8 times 5, that would be 40. So it's a 0 here, and then at 4 extra tenths. And 5 times 4 is 20, plus the extra 4 would be 24 tenths, or 2 hundredths up here. And 5 times the hundredths would be 15, plus 2 is 1,700 extras. And then 5 times 1 is 5 thousandths, plus 1,000 would be 6,740. Now, the multiplication of whole numbers is based on a property called distributive law. This, by the way, is a very, very important law, and you'll encounter it many, many times in the future. But it says that to multiply a number by a sum, a times b plus c, we can multiply each addend by a and then add like this: a times b plus a times c. So therefore, we can say a times b plus c is the same as a times b plus a times c. That sounds pretty abstract. So let's look at some numbers. For example, if we look at 4 times 2 plus 3, 2 plus 3 is equal to 5, so 4 times 5 is 20. Now, on the other hand, we can also write this as 4 times 2 plus 4 times 3. and 4 times 2 is 8, and 4 times 3 is 12, and of course the result is equal to 20. So what's the difference? Well, first we add and then multiply. Here we multiply and then add. That's the only difference. The results are the same. In other words, 4 times 2 plus 3 is the same as 4 times 2 plus 4 times 3. In example number 5, 45 times 23, we can think of it as 45 times 3 plus 20, and then 45 times 3 would be 135, and 45 times 20, that is 900, so the result is 5, 3, 10, so 1035 for number 5. Similarly, for number 6, we have 48 times 3 plus 60, and 3 times 48 is 144, and 60 times 48 is 2,880. So when we add these two numbers, we get 4, 12, 0, 3,024. And for number 11, we multiply 2,344 by 5, which is 20, 2, and then 15 plus 2 is 17, and 2 times 5 is 10, plus 1 is 11. And now we multiply 2,344 by 6,000, so it'd be 0, 0, 0, and then 6 times 4 is 24, carry a 2, and then 6 times 4 plus the carry 2 would be 26, 2, and 6 times 3 is 18, plus 2 is 20, carry 2, and then 6 times 2 is 12, plus a carry of 2 is 14. So then we add up the numbers, 0, 2, 7, 5, 7, 0, 1, 4. So 14,075,720. And for number 12, we multiply 1,006 by 3, which is the 6 times 3 is 18, 0 and 3, and then we multiply 700 times 1,006, so that's 0, and 7 times 6 is 42, 2, carry a 4, so 42, and then 7 times 0 is 0, and 7 times 1 is 7. So when we add these numbers together, we get, this is a 0 here, 8 and a 1, and a 2, and a 7, and a 0, and a 7. Sorry about this, didn't line up too well. So the product is 707,218. For number 13, we multiply 0 times 472, which is 0. And then 3 times 472 would be 6. And 3 times 27 is 21, carry a 2. And 3 times 4 is 12, plus a carry of 2 makes it a 14. And then 8 times 2 is 16, carrier 1, and 8 times 7 is 56, plus 1 is 57, 1, 5 rather, and then 8 times 4 is 32, plus a carrier of 5 makes it 37. So now we get 0, 6, 7, 4 plus 7 is 11, and carrier 1, so it gives us a 9 and a 3. So the product is 391,760. So in exercise number 14, we are multiplying 2,344 times 400, which gives us 0, 0, then 4 times 4 is 16, 1, and carry 1, and 16 plus 1 is 17, carry 1, and then 4 times 3 is 12, plus 1 is 13, carry 1, and 2 times 4 is 8, carry plus a 1 is a 9. And now we multiply 2,344 by 7,000. So it gives us, first of all, 3 zeros. And then 7 times 4 is 28, carry 2. 7 times 4 is 28, plus 2 is 30, carry 3. And 7 times 3 is 21, plus the carry of 3 makes it 24, carry 2. And 2 times 7 is 14. And the carry of 2 makes it 16. So now we add these two numbers, and so we have 0, 0, 6, 7 plus 8 is 15, carry 1, it gives us a 4, and 9 plus 4 is 13, carry 1, gives us a 7. So the result is 17,345,600. That would be the result for number 14. Multiplying by a factor of 100 is really quite simple. We add 2 zeros to the last digit, so it's 5, 6, 2, 0, 0. 56,200. By 1,000, it's very similar. We add 3 zeros to the end, the last digit. So it'd be 5, 6, 2, 1, 2, 3. So 562,000. This would be 56,200, and this would be 562,000. When we multiply two numbers, we can change the order of the numbers without changing their product. For example, 3 times 6 is 18, and 6 times 3 is 18. And this illustrates the commutative law of multiplication. A times B equals B times A. In a way, it's similar to the commutative law of addition, where A plus B equals B plus A. So this also holds for multiplication. Find the product of 23 and 47, so 23 times 47. Would be 1,081. And 47 times 23 is 1,081. So when we compare the answers, we can say they are the same. The answers are the same, just as you would expect it. And then, similar to the associative law of addition, we have the associative law of multiplication. In other words, when we group the numbers, A times B times C is the same as A times B, and then multiply by C. So when we multiply 5 times 2 times 4, would be 10 times 4 would be 40. In other words, 5 times 2 is 10, times 4 is 40. Or if we multiply 2 times 4 is 8, and 8 times 5 is 40 also. So that would be either way. Similarly, if we multiply 4 times 2, well, let me just write it out. 4 times 2 times 6 is equal to 48. Or we can write it as 4 times 2 times 6, or 4 times 12, which is also equal to 48. So in other words, that shows how we can apply the associative law of multiplication. A very simple application of multiplication is to find the area of a rectangular region. If we look at it as the number of square units needed to fill it, so here we have a rectangle 4 inches long and 3 inches wide. It takes 12 square centimeters to fill it. So 3 times 4 is 12, and that's where the 12 comes from, 12 square centimeters, where this would be 1 unit, the square unit of 1 square centimeter. And of course, finding areas is always important. When you rent an apartment or buy a house or something like that, one of the most basic questions is how many square feet. Or in Europe or other metric nations, with the metric system, they ask for square meters. But anyway, it's always an area that's measured in terms of square something, square feet, square meters, or countries, of course, on square miles or square kilometers. So finding areas happens in many, many different ways. So practical application would be where someone wants to paint a room. So Ben and Elizabeth plan to paint one wall of a bedroom in a dark accent color. The wall is a rectangle 12 feet long and 8 feet high. Determine the area of the wall. Well, area is length times width, so 12 feet times 8 feet. And there would be 96 square feet. And why is this relevant? Well, it's relevant because you want to buy enough paint to be able to cover the wall. And so one of the first things they're going to ask if they want to paint a wall, they say, well, how much paint do you need? And that depends, of course, on how many square feet you want to cover. And so based on, let's say, 96 square feet, almost 100 square feet, you buy the right amount of paint. And notice that foot times foot or feet times feet is square feet. So the units of measure have to agree. And this concludes section 1.4.